Hello everyone, welcome to the channel. Today in this video we will be seeing how a new AWS environment can be set up using Terraform. Now this is a continuation of the previous video wherein we created the new production environment from scratch using the AWS graphical user interface. Wherein this time we will be doing it using the infrastructure as code, and the tool that we would be using for that is Terraform. So let's get started. For this, what I'm going to do is I would be creating a new folder called as demo class. This is an empty directory as of now, so there is no hidden files or no files existing in this directory, and I open this in my Visual Studio Code. So as you see, this is the empty directory, and I start by creating the Terraform configuration files. So before we get started, so I'm currently logged into my AWS account, and I would be going into AP South 2 region, which is the Hyderabad region. And as of now, you see that there is 0 VPCs that are currently existing in this region of mine. So we will be configuring our Terraform code to create the VPC in this region and use those availability zones to create the subnets and other components of our VPC. So this would exactly be your new production environment setup, but it would be with Terraform. So to begin with, what I need to do is search for Terraform AWS VPC, and if you hit this, you should be going into the first one, which is a module. I would definitely request not to go into the module section if you are a beginner, but go into AWS_VPC resource section if you want to create that VPC from scratch. The first thing that you need to do when you are working with Terraform is to know how to use the provider. So to get that information, you could always go to the extreme right and look for use provider details, and this is the configuration that I should be using for my provider. So I'll come back to my code and I would create a file called as provider.tf, and I'll paste this code over here. One thing that you should be aware is, so this is currently using version 3.3.0 for of HashiCorp AWS HashiCorp version. But here if you see, a newer version is available is what is being displayed on the screen. So you could always go to the latest version of the code, and once this is there, you should be able to copy this from the top. So this is what we have, and you could copy this from here. So these are the minor details that you should be aware of when you're writing Terraform code. So just be careful about the various error messages or warning signs that are there on the screen, and you should be acting accordingly with them. The next thing that I would be doing is configuring my region in which I want to operate. So as discussed, I want to operate in AP South 2, the region AP South 2. Now, if you don't want to hard code everything on your AWS configuration files, and if you want to maintain separate variable.tf files or a variable file, you could always do that by giving AWS_region. So I define the variable called as AWS_region. What I then do is I will define the value of this AWS_region in a file called as terraform.tf var, terraform.tf vars, and this would be AP South 2. So I've just done that, and for the provider.tf, what I will now do is I will replace this with var.aws.region. So this is perfectly completed. Let's try to initiate the code or the block and try to see what changes happen once I do that. So Terraform init is what I would be doing. If you're wondering how Terraform should be installed, the installation steps is very easy. All you have to do is On the Google search page, go to Terraform download for Windows, because I'm on Windows, and I would be going into the first link that is provided there. Because I'm on Windows, I would be doing this, and I would be downloading the file. Because I am on AMD Ryzen, I would be selecting the second one and I click on download. Now what I do with this is I would keep this into a certain location, which is on my laptop. I'll keep it inside this location. The reason why I'm keeping it into a certain location is I have added this particular path in the system environment path. So that is, if I go to properties and if you look at advanced settings or the environment variable, so you would see that in the path I have defined cabhi bin as a folder path. So what happens is, if I have any executable files like the Chrome driver or the Terraform file in this case, that file is automatically available, or this exe file is, the command is automatically available when you try to execute the shell. So I will not be creating this, because if I do a Terraform again, so you would see that the zip file is also coming up, which is something which we don't need. So I will delete the zip file as of now. So delete the zip file, and if you now do a Terraform, you would only be able to see two of the things. TerraGrunt is the other one, and this. Now you've seen that the Terraform initialization is successfully completed, and if you take a look at the structure, you would see that a .terraform folder has been created. So let's quickly see what is there inside the .terraform folder. ls .terraform. You would see that it has providers. If you go for a providers, you would see that it has a register. Inside register you have HashiCorp, and inside HashiCorp you have AWS. AWS we have version 5.4.0, and this would actually have Windows AMD, and this would actually have your exe file listed. So you could also use a tree option if you have the tree command installed on your operating system. So you could use the tree to just visualize what the folder structure is. So you could use, with the use of tree, you would be able to see the folder structure. So there is a .terraform folder. Inside that there is a folder called as providers, which follows with registry.terraform.io, which follows HashiCorp, then AWS, then 5.4.0. Because I am on Windows AMD Ryzen, so this is the folder, and this is exactly what is downloaded. I clear the screen, and the next thing that we would be doing now is creating a code for writing or creating our VPC. For this, I would be creating a main.tf file. So I could actually name this file anything like a network.tf or a backbone.tf or anything. But because main.tf is a standard practice, I would be going ahead with that. Now that we have created the main.tf, so let's try to understand how we could create the code. For this, what I'll do is search for the variable AWS_VPC and try to see if I get that option or not. So if you just scroll down a bit, or what you could do is do a Control F for VPC, and it should directly take you to that piece of code. You just do it for AWS.VPC, so this should take you to the exact piece which is creating the VPC resource. Now this is the VPC resource, and if you just want to create a VPC without any tags, you could go with the first option, or else if you want tags to be added, you could go with the second option. I would prefer tags to be available on the VPC, so let's do this. And what I'll try to do is also add some variables along with this. What I do is I'll define a variable called as AWS_VPC, or I'll just use it as VPC_CIDR_BLOCK block. I'll save this, and what I need to do is copy this code, put it in Terraform.tf fast, and I would need the CIDR to be defined here. So that would be 10.0.0.0/16. Now that this is done, so what I'll do is come back to my main file and replace this with var.vpc_CIDR block. The tenancy would be default, so I'm not going to change that. What I'll also try to do is add a new variable called as batch name, batch underscore name, and I'll leave that as blank. And what I'll do is change this, provide a value. So I'll do this, and this is a demo, so that is cp demo. I'll just leave it as it is. And the way in which we can add this into double inverted commas is I would just have to do this dollar, open the curly braces, that is var dot batch name hyphen, I'll say VPC. That's it. I'll change this to my VPC, my underscore VPC, and this. There's a small caveat, so I'll also be adding some comments. This block will create our VPC in AP South 2. How is it going to create it in AP South 2? Because we have provided the region in the provider.tf as AP South 2. So all set. So what I will now be doing is running Terraform plan, and you would see that it would give you a detailed plan of what it is going to perform. So as of now, we see that it is going to create. So you see the plus sign over here. It's going to create, and it's creating a resource called as AWS VPC, and that is named as my underscore VPC and my file. So I'll just say Terraform apply, and this should actually initiate the apply process. It will again give you the plan which we need to agree with, and if you say yes, so that would actually create the AWS resource or the VPC for you. If you just look at this, so if you refresh the page in the Hyderabad region, I should be able to see a new APC being created for us. So this is the VPC cider range, and you would see that it is cp demo hyphen VPC. The next thing that I need to create with this is the internet gateway. If you're not very much familiar with AWS, right, I would always recommend you to draw an architecture diagram for the resources that you are about to create, and always make a tab of what is being created. So let's quickly create our architecture diagram using OneNote, and then we would keep checking everything that has been created so far. So I would be creating an architecture diagram which should be high available. So for that, what I would be doing is I would be actually creating my architecture diagram. So this is the VPC. The VPC cider range is 10.0.0.0/16. What I'm going to do next is going to create an IGW which would be connected, attached to the VPC. So this is number one. What I would be doing is having two subnets in each availability zone. So this would be availability zone 1, and this should be, the other one should be availability zone number 2. So I'll name the subnets as subnet 1, subnet 2, this is subnet 4, and this is subnet 3. I then have route tables, so which I would need. So I would basically be having two route tables. So these route tables would be created or attached to individual subnets. So what I would be doing is attaching this route table and giving the route to the internet as IGW. So this would become a public route table, and these two subnets would then become public subnets. Similarly, what I'll be doing is I will be having another route table which would be drawn over here, and I'll provide a NAT gateway for this route to the internet. I would be creating the NAT gateway over here, and I would be assigning these two subnets with this. So these two subnets actually become the private subnets of ours. Obviously both the subnets should be having so all the subnets, right, so both the private subnet and the public subnet should be having an NACL around it. So this is the NACL that I would be drawing around these subnets. So this is NACL for the public subnets, and this is the NACL for the private subnets. So this is the architecture diagram that I have come up with, and let's try to create the things and keep taking things one by one. So far we have already created our AWS account. So this thing has already been done. So I'll just draw it as green or mark it as green. So this is already done. The next thing that I need to do is create our IGWs or the internet gateway. So we already know that it is called as internet gateway. So what I'll do is remove everything and call it as internet underscore gateway, and you would see that there is something called as internet gateway. Now if you're not able to find it with an underscore gateway, and if you fumble with internet gateway, you still would be able to get it, because the documentation is clever enough to give you the details. So you'll go to the resource block and you would have to do this. Just copy the thing and take it to your VPC, which is this, and put it inside the main.tf. So I'll just give a comment. This block is going to create the IGW, and the next thing that I'm going to do is resource add the resource to this. I'll call it as my IGW, and here if you see the VPC ID is being referred to as AWS underscore VPC dot main dot ID, but the name in Terraform that I given to my VPC is my underscore VPC, which should be changed to this. Again, the batch name would always be a problem. So what I'll do is change this to this, and I'll just call it as IGW. Now what is going to happen is this is going to create the IGW, and this is also going to attach the IGW to our VPC. This is actually happening. This is actually happening because of the line number 15, which has been provided, which is the VPC ID, which is generally not provided or required when we create the internet gateway from the console. What I'll do is do a Terraform apply again, and this time you should be able to again see that Terraform code is going to create one new resource, and this is the internet gateway this time. I'll just say create yes, and this should have created the internet gateway for us. If you go for internet gateway, which is the third option in the VPC dashboard, you see that the internet gateway is created and it's also attached to our VPC. The next thing that I would be creating is I'll fall back to our architecture diagram, and I'll just enlarge it a bit. So we have already completed the VPC. We have already completed the internet gateway. The next thing that I would be creating is subnets. So I would be coming back to subnet, and what I should be doing is searching for something called as AWS underscore subnets. So if you see, I find AWS underscore subnets, and this is exactly what I need. I can create all 4 subnets at once. So what I will be doing is going here, I'll add the comments. This block is going to create our subnets, right? And I put this. The first thing that I need to give is my underscore. This is subnet underscore 1. So I'll give it as this. This changes to my VPC. So that would be my underscore VPC dot ID. And you could either leave the CIDR blocks over here, or you could change the CIDR blocks to your variables.tf file. I would leave them as it is for now, and I'll just give them a subnet 1A. The reason why I am giving it as 1A is because I want this subnet to be exactly created in 1A, the availability zone 1A. Let me just add, we create this subnet in AZ 1A. But then the problem is in this piece of code you have not defined availability zone in any which way. So what we do is come to the documentation down, and we try to figure out if there is anything called as availability zone that can be added at the time of giving the code. So you see that there is something called as availability zone, and there is something called as availability zone ID. What I'll do is I'll choose the availability zone option, and this is optional. This is AZ for the subnet, It is the AZ ID of the subnet. The argument is not supported in all region or partition. It is necessary, if necessary, use availability zone instead. So basically what they're saying is it's better to use availability zone. What I'll do is provide the availability zone. Now, what we don't know is will it take just the ID 1A or will it take the entire thing AP South 2A, right? So we are not aware of that. So what we'll be doing is doing some trial and error. Now because this is AP South 2, so I have already changed this to subnet 2A in my tags. What I'll be doing is, let's try to run our VPC, the Terraform apply, and try to see if it actually creates the subnet or if it gives us any error. So the Terraform plan as of now says that it's gonna create something. So let's hit on yes, and let's verify if the thing has been created or not. So as you see, the subnet has been created. Now what we would be doing is checking if the subnet was created in availability zone 2A or not. And as you see, this availability zone has been created in subnet 2A. The next thing that we would be doing is replicating the same model and create other subnets in other availability zones as well. So I'll be creating my subnet 2, and this would then become my subnet 2B, and I would provide this in this thing. Now what I've realized is we should also be giving the public subnets and the private subnets. So what I would be doing is changing the name of my current subnet that was created to public subnets. And similarly, what I'll be doing is creating something for private subnets as well. So I'll just do this copy and I just paste it. And here I need to change my stuff to subnet number 3. This is subnet number 4 for me. The one that I've just created, want it to be a private subnet, and I want this to be a private subnet. We need to be sure that we are changing the CIDR ranges, so that is something that you should not be forgetting to do. So the first CIDR range is 10.1.0, the second one is 10.0.1.0, the other one is 10.0.2.0, and so on and so forth. So we should be very careful with the CIDR ranges. The next thing that we would be doing is trying to see if it actually creates the CIDR ranges or not. So let's try to do this, and if I do an apply, it actually gives us an error saying that the CIDR block for subnet 4 is not proper. So I'll go into the code and try to remove or get rid of the typo that happened there, and everything else looks perfect to me. I would be creating this, and this should be creating our subnets in the region. So as you see, the subnet is created. So I'll quickly go to the AWS console, and you should now be able to see 4 subnets existing there. And in the meantime, what has happened is the other subnet that we already had, right, because there was a change in the name. So actually Terraform told us that it is creating 3 things, and it is actually going to change one thing, and that one change is basically the subnet name. So it actually changed the name of the subnet from sub 2A to pub sub 2A. So we now have basically 4 subnets, which is 2 public subnets and 2 private subnets as of now. The next thing that we should be creating is route tables and network access, so NAT gateways. So I'll first be creating the route table, which is so this is AWS route table over here, and this has a small warning signs that you have to go through. So we'll just so we got this code, and we'll just copy this and we would paste it in our code, which is there for this. So, and we'll just paste it over there in our code. Now before that, I'll add a small comments over here. So this log is going to create our route table. Now because it's creating a route table and we are going to give route to the internet via the IGW. So this is another thing that we are going to do. So we are going to provide the route to the internet via the internet gateway. So because the internet gateway route, so route to the internet is 0.0.0.0.0.0.0/0, and what I need to do is select the internet gateway. You would see that we have already created an internet gateway at the very beginning of the code, and all I have to do is give it as my IGW. So I'll just change it to my IGW and I'll say it as my public underscore route table, right? And obviously what I need to change is the VPC ID. So VPC ID would become my VPC dot ID, and that should be it, because we are not going to use any of the IPv6 blocks. So I would be removing that, and I would be transforming or changing this part of the thing with this hyphen. This is public, this is route table, and I'll be closing the parenthesis. So this looks good to me. Let's try to see if Terraform is happy with it and actually creates a resource, or it complains about the stuff. It says it's willing to create one resource, and that one resource is actually a route table. Let's try to see. It says it created the route table successfully. Let's try to go and see if it actually did that. Seldom it happens that it would not create the thing as expected, but for now the route to the internet looks perfectly okay for us. The next thing that we need is actually a NAT gateway as per the architecture diagram that we have. So we need the small component called as ng so that we can create this route table. So what I'll do is I'll quickly go ahead to the documentation and search for NAT gateway. So that is NAT underscore gateway, and there is a slight possibility that we might find it or we might not find it. So let's quickly see if that is available. So yes, under the VPC we can find the AWS NAT gateway. Now if you know the NAT gateway, which is used for public routing, you would need an elastic IP along with the NAT gateway. So I will first copy this stuff, which is the code for creating a NAT gateway. So I would add the comment, this block will create the NAT gateway for us, and I'll just paste it. Here you see that there is a nice feature called as depends on. We would look into that very soon. And the next thing that we need is an elastic IP. So we currently don't have the code for elastic IP, so I'll quickly search for that, search for this, and you get the elastic IP over here. And what you need to do is just create the elastic IP. Now I'll just copy the code, but there are few extra exceptional changes that we would have to do to get this up and running for us. So what I'll do is this block below will create, not create, it will actually allocate an EIP for us, right? And this is the code. Now if you remember an elastic IP, when you allocate an elastic IP, it never asks us for a domain, and it would also not ask us for an instance ID. So what I'll do is the elastic IP block, I'll just leave it as it is, and I'll just name it as my EIP. That's it. Now what I'm gonna do is I'll change this to my EIP.id over here. I also have to change this subnet, so I need I should actually provide a subnet. So what I'll do is I'll provide one of the subnets, but what I should make sure is this subnet should be a public subnet. So how do I know that? So I'll scroll up, try to see which subnet of mine is a public subnet. So subnet 2 is definitely a public subnet, so I'll create that over here, and I'll provide the ID for that. So this is done, and obviously the NAT gateway would be renamed to that as CP demo NAT gateway, and that's it. It works fine for me. Depends on. So actually our NAT gateway is not dependent on the internet gateway, but it is actually dependent on the elastic IP. So I'll change this internet gateway thing that is there to this, and we know that. So what would happen is if our EIP is not created, which is this, right? If I try to comment out this entire code of elastic IP, and if we say that, and if you try to create that, we would anyways be getting an error saying that elastic IP does not exist. So I could give you a small example of how the error looks like. You would see that even if you run this, so it would say that the managed resource EIP has not been declared in the root module. This is because this is not there, right? Now for any chance or any reason, if the elastic IP has not been created, or it takes time for the elastic IP to be allocated, right? So our AWS or Terraform code for NAT gateway would actually wait for the creation of that thing. So I'll call this as NAT gateway. If you see, for all the resources, I'm actually giving underscores at the top. There is a very small reason why I give that. If I go with a hyphen, if you just double click, right, it's only going to select one part of the entire code. But if you are a seasoned code writer, if you write code on a daily basis, you would love that you just double click, the entire thing should be copied. You should just see the control C and everything should be copied for you. What I'll do is do a Terraform apply. I hope that the error goes away and I should be able to say yes. And this is actually going to create the NAT gateway for us. The next thing that is actually pending is the network access control list. I know the NAT gateway is going to take some time to create, so I in the meantime would go into ACL. I'm basically looking at network ACL, so I would say network underscore ACL. So let's see if we are able to find it that way. Oh yes, so this is network ACL, and here again you see that you have a very decent code that is used for creating an NACL. So I'll just copy the entire code that is there on the top, very simple, and I would paste it on my Visual Studio code. So this block will create NACL for us. We are going to create NACL for public subnets. I'm going to create that for public subnets, and let's see if this works for us. So I'm going to say this as my pub NACL because I want this to be created for public subnets. I call it as my vpc.id. I'll save it, and what I quickly do is still check that my NAT gateway is still being created, so it is totally fine. I could still do my configuration changes into this piece of code. I'll change the rule number to 100 on both the places, and the first thing that I would allow is I'll just allow CIDR 0.0.0/0 to be allowed from the entire network, and I'll do this for the same. And what I'm going to do is allow all ports, that is all traffic, that is port number 0 to port number 65,535 to be allowed. And I'm going to do this same, and I'm just going to do 65,535. So I'm just allowing all traffic to go in and go out of the NACL. Now this is not recommended, but for the purpose of this course, purpose of this video, what I'm trying to do is allow all traffic on the NACL. What I would also be doing is associating all our subnets with this NACL itself, because I don't want to create a private NACL just because it increases the amount of code that is needed. But if you are going with the private NACL, I'll definitely recommend you to watch a previous video of what configurations or what rules NACL should have for your production environment to be working, and then you could make the exact changes over here. Now that this is done, so let's try to see if our NACL is created. So I'll just do a Terraform apply. I'll quickly see if everything is in place. It looks like, so let's see. And I'll say yes. And you would see that the NACL is created. Let's quickly go into our VPC and see if the NACL is actually created. And if you see, the main NACL NACL named as main is created, and the inbound rule is actually allowing all TCP in and out. The next thing that I need to do is we need to change the thing because this is a bit misleading. So what I'll do is call this and just change the name for this as NACL, right? If you notice, the NACL is not associated with all the subnets, so for that there is a separate code. So we would need to go for network ACL association, and I need to associate all subnets with this. If you see, this is actually taking one subnet at a time. So basically what I will have to do is have multiple association blocks for all the 4 subnets that I have. So this block will associate the subnet with NACL. This needs to be done 4 times as we have 4 subnets with us. Great. So looks good to me, and I'll just change this and I'll just add another comment over there. So this looks good. I'll say my subnet 1 with NACL, right, association. I just would change it to my NACL.id, and I would change this to my sub1.id. So looks good. What I'll do is just copy paste the entire thing into 3 more different blocks. I'll call it a subnet 2 because I'm going to use the same subnet, so I'm not going to change anything except for the numbers over there. So I'm just doing this again, and that's it, and that's it. So let's do this. If you're wondering, if you want to add an additional rule on the NACL, and if you're wondering how that can be done or should be done, I'll quickly show you an example code of adding an NACL rule as well. This is important if you are going to create an NACL with our standard procedure of allowing ephemeral ports and other inbound and outbound traffic. So for example, if you want to allow or create a rule which says my NACL underscore rule, let's say this is for RD, let's say this is for SSH, and you want to create it as rule number 20. If you want to create it as ingress rule, you need to leave the egress as false. If you want to create it as an egress rule, you have to make the egress as true. So let's make it as an egress rule. What I want to do is allow, so let's make it as an ingress rule. So what I want to do is false over here, FALSC false over here, and what I want to do is allow port number 22 this, but what I want to do is the CIDR block should be 0.0.00/0. I want to allow it from the internet. I know that this rule is not needed if the rule number 100 says that allow everything from the entire internet, but I'm doing this specifically to show you that this can be done in this fashion. So this is how you would add a new rule. Ideally, so you should also be giving the right public right IDs for this to happen. Let's try to run this and see. I'll do a Terraform apply, and here you see that we are getting an error saying that was already used. So let's see. Okay, so basically this says it is being repeated, so I'll just change that, and let's try to run it again and see if it actually functions. So I'll just double check my code. Everything looks okay for my naked eyes, so I'll do yes, and I should be able to create all 5 resources at a single time. So if you see, if you just refresh the page, you would see that all 4 subnets are created with this. My inbound rule should now be having 2 rules, even though this rule is not added. I just gave you a demo on how to add additional rules. if you only are creating it with one particular rule. And I think everything else is intact. What we can do is maybe host an EC2 instance and check if we are able to connect to that instance or not. So I'll just say instance, and this is the AWS instance that we have, and you could use the same example that we see over here. Or else if you want to change something with your personalized stuff, you could definitely do that. So let's try to copy the entire code, and this is the first time that we would be using our data block in the entire video. So I'll just add some comments. So this block is adding additional rule to the NACL, right? And that's it. What I'll be doing is pasting this block, and this block will get AMI details. Now you could use this, or you could totally ignore this and hard code your AMI ID over here. So it's totally up to you how you would like to do it. I would prefer to maybe pass the AMI as a variable, but this is the data block and I want to show you how the data block works, so we'll use this. Now I don't want an Ubuntu image, but I want an AMI with AWS AMI, so Amazon Linux AMI. So let's actually see how to get the details of an Amazon Linux AMI. So for that, very simple, what I'll do is go into the EC2 section, and I should be in the Hyderabad region itself, and go to AMIs. And here you would not find any of the images. You could go for public images, and you here get a huge list of images. If you find it overwhelming, go to instances, go to launch instances, and in this you would be able to find the Amazon machine image, the AMI ID. Now come back to the AMI console, which is this, and you could enter this, and you would be able to get the AMI name. Now this is the exact AMI name that we would have to provide in the search field, which is this over here, so that the AMI can be searched. So I just do this, and by this we would be able to get the AMI details, right? The virtualization type is HVM, and we need to change the owner details. So the owner is this, so I'll just change this to this person, and that's it. So this way we can create our AMI details. Now once the AMI is done, so what I need to do is I need to change this Ubuntu with my Amazon Linux AMI details. I'm creating a T3 micro over here, so this should look okay. Now if you want to assign a particular security group to your stuff, so you could also create a security group. So you could say AWS_security group, and this is the code that is used for creating a security group. Very simple, and that's it. Make sure that you are not messing anything up with the egress rule in a security group, because that is very much needed. What I'll do is create a security group at the top itself. So I'll say block to create a security group. So let's see what exactly this is doing. So it's allowing TLS, so I'll say my_security GRP group, which is fine. The name is allow TLS, it's totally fine. So basically what it's allowing in the ingress is 443. Now obviously I don't have an SSL certificate kind of setup there, so I'll just allow port number 80. What I'll also have to allow is port number 20, but I'll leave that for now. The egress says that it is allowing this, so we'll just leave it to the defaults. The CIDR blocks, I just want to allow it from the entire VPC, entire world. So what I'll do is just change this to 0.0.0.0/0, and I don't want an IPv6 to be allowed, so I'll just remove that for now. I also don't want an IPv6 over here, so I'll just remove that, and this looks perfect to me. Now this is the security group which is being created. Obviously the name of the VPC has to be changed to .id, right? And everything else looks perfect to me. So what I would now be doing is actually using this in my EC2 instance creation. So I'll just copy the AWS underscore instance again. I'll go back to the documentation wherever we have AWS instances, which is I don't know where. I do a control F, I go there, and here you would try to search how to provide a security group in the section. So you'll just scroll down and try to find if there is any option that gives us the possibility of adding a security group in the mix as an input variable when creating the stuffs. And here I have security group, so all I have to do is copy this and I need to paste this over here. The other thing that we should be very much aware is I can provide a security group dot this blah 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 is security group my security ID. What we should be very sure is whenever we are creating that security group and whenever we're creating the EC2 instance, they both should be in the same VPC. But as of now, you see that we are not defined any details. We are not defined any details as such, which would be telling us in which availability zone or which subnet this EC2 instance is being created. So let's quickly go ahead and look for the documentation again to find if we can find either an availability zone or a subnet details anywhere over here. So yeah, I see availability zone, which is easy to start the instance in, and if I don't want to use this and if I want to put it into a particular subnet, let's see if that is possible or not. And here if you see, it is, we have the option for a subnet ID, so I can provide the subnet ID over here. Now so this is what I'll do, and here I would select my subnets. I'll select subnet number 2, so this is the ID that I would be selecting. Now if you remember, this subnet group that we created, right, is not going to have a public IP assigned to itself. So basically any resource that is created in subnet 2, which is 2B, generally public subnet 2B, the auto assign public IP before settings is disabled at the moment. So let's try to enable that as well. So what I'll do is go back to AWS subnet, and we would have to check for AWS underscore subnets again. Here's the one, and here I need to check for that option. So enable, it is something named as enable public IPv4 addresses. So map public IP on launch, so whether public IP is attached to the instance on launched or not. So this is the one that we should be doing, and so what I'll be doing is going to the subnets again, and I would be doing this for both our subnets, which is, it's either a true or false, so I'll be doing this, and I should be doing this also for my second subnet, which is true, right? And now what I'll be doing is collectively running everything and hoping that everything falls into place and I'm able to create my stuff. So before I do that, so let me change the naming convention, which is always good. So I'll just change this to a subnet. So I'll just change this, and this is EC2 1, EC2 1, right? So I'll just do that. Fingers crossed, we do a Terraform apply and see if that actually works or not. Okay, and we get the error saying that for security groups, it says in AWS instance, it says that it needs a set of strings required. So basically, wherever you find security groups, right, if there is an S, that basically means you need to provide a list of things or an array of items. So if you just put it under double inverted commas and you put the same thing, you should be able to fix the error, Okay, still gives me an error. So this is okay, okay, and I know why, because this should end with an ID. And let's see if this helps me fix the issue or not. Terraform apply again, and this time it's asking me a yes or a no question. I say yes, please create the stuff. So this is actually changing two things, and if you see, this has altered the subnets. The modification is done. The security group is being created, which is great. The AWS EC2 instance is also being created, and this is the EC2 instance ID that I have got. So let's quickly go into our EC2 console, which is already open. I'll go into EC2 instances and see if the EC2 instance is up and running or not. And yes, I also have an IPv4 address attached to that. Now what we can do is connect to this and try to see if we are able to connect or not. I'll just quickly check the security group. Now you're only allowing port number 80 on this security group. Now if you want also to have your port number 22 to be allowed on this security group, so you would have to go to the security group tabs again, and here you need to select security group rules, and we would have to create a new rule for us. I'll just create a new rule. So what I'll do is I'll place the rule at the very bottom of the page, and this is my SSH rule, and this is ingress. Yes, the port number is 22. I need a 22. This is TCP. The CIDR blocks, I actually want it to be available from the entire internet, so I'll do it as 0.0. Sorry, it should be in inverted commas. So 0.0.0.0/0. And it's asking me for IPv6. I don't want any IPv6 IDs, so that should be fine. And it is asking us for the security group details, so I'll probably paste the security group ID from the above and put it over here. So what this should be doing is this should be actually adding a security group rule to our system. So it's actually making 3 changes. So let's quickly see what they are. So it's actually regrading an NACL rule, which is totally fine. It is destroying our EC2 instance, which is strange, but we would have to see why that is being done. So to understand why an EC2 instance is being destroyed, so we could look at this option over here, and if you just scroll to the top, which is resource AWS, and here you would find the exact reason why this is being recreated. So if I just scroll down, so here if you see security groups, it says a force replacement. Now because there was a change in the security groups, I believe that is the reason why this is being recreated. So let's quickly see what changes is being happening on that security group. So this is the security group ID, which I should for some reason have it. Yes. So let's see if a new security group was created or if an existing security group was modified. So I'll just open this security groups page. Yeah, the security group is still there, and the inbound rule should now actually have two things: SSH as well as port number 80. And a new EC2 instance is created with place of that. So you can do this, and if you see the EC2 instance is already initializing, the older one was terminated and the new one was created. Now what I can do is connect to this EC2 instance. I could go into the directory. So I could connect to this EC2 instance, and for that I definitely would need my key pair to be associated. Now if you see that the key pair that was used to launch was not given at the moment. So from this what we know is if you want to create an EC2 instance, you also need to provide the key pair with the EC2 instance configuration. So what I'll do is I'll probably change the configuration again. So we are looking for AWS underscore instance, which is nowhere to be found as of now. So yeah, I found this, and here you need to find something for key pair. Let's do a control F for maybe for key, and I have some details, and this is the KMS key ARN, which is not what we are looking for. This is the KMS or the key name that I have to give when creating the EC2 instance. So let's quickly go there, and this is the security group block, and this is the AMI, and this is the one. So here I have to add the key name as well. Now I'll probably provide this as a key underscore name thing. This is the key pair name, and I'll probably provide this as a variable block. So I'll add the variable again and put it over here, and the Terraform TFRs I'll actually provide this, and the key pair that I would select is an existing one which is there. So I'll go into the EC2 dashboard and look for key pairs. In the extreme left, you should find key pairs, and here I could select any one of them. So I'll select CPB00 AP South 2. This is the key pair that I'll select. I'll put this in double inverted commas. I'll save it. Now if I run the same thing, it should do the trick. This time I hope the EC2 instance is not terminated. So let's see. It still says want to destroy, so we would have to see what that is. Yeah, this time obviously yes, the EC2 instance would be terminated because it would be creating a new one with the key pair being selected. So as you see, the EC2 instance was recreated. So let's quickly go into the EC2 console and see if the new instance is up and running, and you see that a new instance was created. Now if I try to do a Terraform apply again, right, this time I should not see an EC2 instance being recreated. Now that is the expectation, but we never know. So let's quickly go and try to see what exactly is happening. Now okay, so I still see that the security groups is actually forcing a recreation of the EC2 instance of our web server. So now this is not a great sign. So let's try to understand what is wrong and why this is being created. So what we have used over here is in the main.tf for the EC2 instance block, what we have used is security groups. Now instead of using security groups, what we should probably be using is VPC underscore security group. So this is one of the Terraform modules that I've seen, and so they have recommended us to use VPC security group IDs. So let's quickly see if there is an option for that. So we would quickly go to security groups. So this is the associated security groups, but we also have a VPC security group IDs. Now VPC security IDs, as it says, is associates a security group for a non-default VPC. But and if you're working with a default VPC, you should be using security groups. And what I'll do is replace this with my VPC security groups. So I'll quickly go there and replace this with this IDs, and everything else should look good to me at least. And this time I'll again do I'll just cancel everything and I'll do a Terraform apply again. This time it obviously would be doing some more stuff, and probably a yes. And this time if you see, this is not destroying anything that is already created, because it's already able to see that that security group which was already there is there, and it's not going to destroy or recreate any other thing. Now it's only changing two things, that is, it is updating the NACL rule and the security groups, which is totally fine for me. At least the EC2 instance is not getting destroyed. I'll go into the EC2 console and see if my EC2 instance is already up and running. Yes, it is, and I would connect to my EC2 instance. So I'll go into the directory where my PEM keys are, CABHI cloud keys, LSFNL. There should be a huge list of keys that I have. So what I'll be using is clicking on connect, and I'll use the example to connect to my EC2 instance. I'll just right click, and if I do this, I should be able to connect. But the only problem is, you see that it is trying to connect with the root user, whereas because I am using an EC2, the Amazon Linux machine, so it should be using the EC2 user to connect to the server, and looks like there is some alteration that is needed somewhere. So let's try to see what exactly is causing the problem for not connecting. So obviously for troubleshooting, we would be using the AWS console to understand what exactly is not working as needed. I suspect all things are allowed, and the firewall rules should be the one which should be causing us some problems. I am already allowing both the things to come in and go out, which is fine because I'm using it in a public subnet. So the route table, the public route table should be allowing the route to the internet via the internet gateway, which is already fine. Though I'm not using NAT gateway, so that's the reason, because I would not like to connect with that. The other thing is, I'll go into the EC2 instances and go into the security channel and maybe check for this and try to see if I am allowing port number 22. Oh, so you see that port number 22 is not allowed, and we'll have to see why this was not done. So let's quickly check if this still applies. Yes, code is still there. So let me quickly check why this did not work. Let's try to run a Terraform plan and see what exactly is happening. So I do a Terraform plan, which is plan, and we should be able to see what exactly the problem is. So boom, and if you see, it says it wants to add something. Yes, it is trying to add few things. So let's see, do a Terraform apply this time and see if it is adding the resources or not. I'll do a yes. Okay, it says it has added two things. Let's do a Terraform apply. At least this time it should say that there should be no changes. It still says there are some changes, but I will not be allowing that. So let's quickly look at the security group rules. Is it allowing port number 22? And it looks like it is now allowing the security group rule. So what I'll do is quickly go into my stuff and connect with EC2 user, and this time, so as you see, we are still not able to connect to the EC2 instance. So the EC2 instance is still not able. We still are not able to connect to the EC2 instance, and while troubleshooting, so I did see that the EC2 instance was created in this subnet, and this subnet is associated with the following things. It is associated with the NACL, which is totally fine, and then it is associated with a route table which is not having any routes. And if you see, this route table is, I guess, a main route table and not the route table that we created for us. So what we might or have forgotten is associating the route table with the subnets. So what I'll do is go back to route tables. I'll go back to route tables, and that is, I guess, table, and we need to check for route table association this time. So route table association is what I need to do, and here I need to associate our route tables with this. So obviously we would have to associate the route tables in a sequential order again. This would be a similar process. So what I'll do is do this. So I'll say my pub rt association party with sub 1, right? And I need to provide the subnet, so that is my subnet. I'll just do 2.id because I want to associate this as of now. I'll just select this .id because I want this to be working. I'll do one thing. So what I'll do is come back to my Terraform module and say Terraform apply yes, and would see if what all changes is being done. So what I see is it is adding one thing, which obviously should be the association, but what I also see is we'll be updating in place. So this is self is false, So basically what it's trying to do is it's also going to change the ingress rule of my security group. Now this is something that we would like to avoid. So nothing that I could find, so I'll do a Terraform apply, and this should actually update the subnet association. So this is done. What I'll do is quickly see if my route table is now associated, my subnet is now associated with the correct route table, and the route table should be having a route to the internet via this. I'll quickly also check if the security group is having the perfect rules, and yes, it has all the rules that are needed. And now what I'll do is try to connect to my EC2 instance, and you should be able to see that I am, and our EC2 instance should also be associated with the right security group, and the security group should also be allowing all the traffic. But if you see, the security group currently is not allowing the traffic inbound, so I guess the Terraform apply actually changed that. So if we do this again, we should be able to find our things. So this is adding 2 stubs, which is good, but then this is a bug which we would have to fix somewhere in the later section of the course. So if I now try to connect to the EC2 instance, which is this, I should be probably be able to connect to the EC2 instance. So this way so you should be able to connect to the instances. I could do a curl for https google.com, and that should be working as expected, because already all the ephemeral ports are allowed. So this is exactly how you would set up your entire environment of AWS using the correct parameters. So as you see, this is a 241 line long code. We have not given some of the comments to some of the blocks, but this is overall how you would create your Terraform code, which would be creating your infrastructure in place for you. That's it for this video, guys. So hope you like this video. Thank you so much for watching. If you're not subscribed to the channel, please subscribe to the channel. Thanks for watching. Keep having a great day.